Hello, everyone. My name is Calvin Rumsberg. I am a systems engineer here at Juniper Networks. And today we're going to talk about something that's pretty cool. We're going to talk about the two most popular automation frameworks in the networking industry today, kind of figuring out where they fit and which one to use in certain situations. Kind of a heated topic, but we'll at least share a little bit of what my perspective is on that. So, since we're talking about networks and automating them, the target audience, if you're interested in either networking or automation, well, then you're probably in the right spot. And if you don't care about networking, don't worry. You're still going to learn something. It might actually end up being a fun session. And now it would help if you had some previous experience, either hands-on or just watching videos on things like Python, lists, dictionaries, YAML, and even if you've got like your own interpretation of what the word DevOps means, which is technically what we're going to be showcasing today, then that's as well just as good. We'll be sharing my personal take on the word DevOps. It's kind of a loaded topic, but we'll get to that just in a second. So the objectives today, we're going to give a understanding as to what kind of problem automation frameworks are designed to solve for us, because we can technically do everything with just scripting Python, Bash, and we should be sufficient. So why even consider using an automation framework, and how they're structured in order to accomplish the goal that they've originally set out for. And again, we will talk about when it makes sense to script things, and then we'll say also when it makes sense to use an automation framework. You might find yourself in one camp where you're all team script, or you're all team Nornir, right? Or you might find yourself in a hybrid situation where you will use automation frameworks as much as possible, and bust out some scripts when there's a gap there. We will be covering again the two most common automation frameworks on the market today. That's Ansible, and then also Nornir, which is a relatively newcomer. Uh, but first, let's talk about something heated. Let's talk about what DevOps actually means. And not to be too controversial, but this is my interpretation. I'm quoting myself because this is I don't necessarily align with most interpretations out there of what DevOps is, but for me it's really simple. It's just using developer tools to help manage our networking infrastructure, and other kinds of infrastructure too, servers and that sort of thing, but most specifically for networking. So that's it. It's controversial. I don't know why some people like to throw a lot of other things at DevOps, like agile methodology, Scrum. Go for it. This is just what I view as DevOps, and hopefully that's relatively easy to understand. So, what is the common goal, right? Again, the way that my mind likes to solve or to understand things, I like to understand the problem first, and then talking about the solution kind of makes a little bit more sense to me. So, what is the problem? What are we looking to solve with automation frameworks? And not to be anticlimactic, it's really great, but it's to make it easier for us to automate, to make our lives a little bit easier. And there's a lot of different contexts as to what's easier and what's harder. Hopefully, we'll touch upon some of these things, but that's it. That's all automation frameworks are here for. They're not here for our money. They're typically always free and open source. So this is it. This is the reason that they exist. And argument, it might be arguable, but I think they're outstanding. So talking about what the automation framework actually brings to the table, I've created this graphic. It's a little busy, so I'd like to take some time to kind of pull apart, but hopefully walking away from this slide here, you'll have a little bit better understanding of what it is that an automation framework is bringing to the table to address some of the challenges of making it easier to automate. The first thing is that automation frameworks typically have some kind of concept of inventory management. But and that's when I say inventory management, I mean just basically a list of this device to this IP. Maybe it's got this attribute. Right? We've got dozens, maybe hundreds, maybe thousands of network devices in our environment. So we need some kind of list, and that's what an inventory aspect of an automation framework allows you to do. Typically, they have plugins that allow you to integrate with other inventory systems that might be in your environment. Things like SolarWinds or Netbox or Infoblocks. There are methods of getting the information from those trusted sources and ingesting it at either runtime or beforehand. So inventory management is a crucial part of your automation. If you think about how would you even begin to automate 10,000 switches if because every switch has a different name? Are you going to make 10,000 revisions to the script? Of course not. So inventory is a huge part of scripting. So having that kind of prepackaged and available for you within a framework with specific rules, that really helps a huge load off your shoulders. The other thing is that they typically have a lot of plugins that are created either by the community or, in the case of Ansible, for the most part, generated by the networking vendor themselves. So they're typically an outstanding block of code that you don't have to develop for yourself, right? So this is things like managing an SSH connection to a router. You don't want to have to write that. You don't want that driver to be on your shoulders. So to delegate that to the actual vendor that makes that software or hardware product, well, that makes a lot of sense, doesn't it? So there's a lot of really amazing plugins available, especially in the Ansible side of things. And Nornir will talk about that as well. But plugins, again, having reusable blocks of code that you don't have to actually develop yourself. You just kind of pull it off the shelf and say, hey, I want to do that. I want to create a VLAN. I want to pull down this module or this plugin. It's pretty nice. Pretty darn nice, I got to say. Now, let's talk about something else. And that's execution. And I talked earlier about like the pain of having to have 10,000 revisions to a single Python script if you had 10,000 devices. It's not practical, and there's other ways of doing things. But keep in mind that we've got many, many, many devices in our environment. And if you fell back onto Python's default behavior, Python's what we call single threaded, meaning basically the default setting of Python would be to run one SSH connection to one device, perform some operation, log out of that device, and then go to your next one, execute, come back. That is what we would call kind of like a serial methodology. And if you have got hundreds, thousands of devices, your script's never going to have enough time in the day in order to complete, but based on what it's trying to do and how many devices, obviously. But what automation frameworks bring to the table is the ability to execute multiple iterations of the same task to different devices at the same time. And they are structured in a way that they can handle the response data from each device and make sure it's unique within the return value. That alone is worth all the money of an open source project. No, but I mean it's worth, if nothing else resonated with you. Speed is such a crucial thing. So to not have to worry about learning Python libraries like async.io, which is arguably pretty complex, and just pull something off the shelf like Ansible or Nornir and allow it to do it, well, that's a huge burden that's lifted off your shoulders. The other thing is just here is the automation frameworks are typically really great about being able to handle the results. Obviously, for any kind of task, Ansible task or a Nornir task or Terraform or something else, you want to know whether or not it was successful or not. And then sometimes you want to take that data, that result of your automation playbook, and store it somewhere, right? Maybe like an audit log, or I don't know, maybe a Slack channel, something like that. You want some visibility to each one of those. There are methods and plugins within automation frameworks that let you handle that data so you can share it more easily available. You can do all kinds of things with it. So that functionality is just also fantastic. So let's cover Ansible first. This is King Kong right now in the network automation space, and for very good reason. I am personally a very big fan of both projects, but I use Ansible a lot more, and it's just a personal preference. That's all. So Ansible, let's give a little bit of overview before we actually go and cover some of the ins and outs of the project itself. So the product was completely open source project back in 2012, in simpler days. Purchased by Red Hat, which is now owned by IBM, back in 2015. And the focus was not initially on network devices. And in fact, if you kind of peel back the onion as to how Ansible does some of its magic on networking devices, you'll kind of understand what I mean about it had never had the context and focus on networking. It was all server automation and application deployment. But Red Hat helped kind of steer the shift in favor for networking devices because there was really nothing good out there for us. So thank you very much for that, Ansible. And the goals of Ansible, again, really easy to understand, argumentatively, but it's easier than other things out there. It's effectively simple to set up. There's really just one command that you run, and everything is on your machine and ready for you. And extensible. We talked about this earlier with when we talked about the value of a plugin ecosystem, being able to deliver extensions that further the product or better the code. That's a really good thing. And on the right hand side of this, what we see is just an example of an automation or an Ansible playbook. In this specific playbook, this is going to log into a Juniper device, and it's going to, oh, you can't even see. Let me hide my face from you. Okay, so in this playbook on the right here, we're basically logging into a router, and we are changing its host name to router 1. So fairly easy to interpret. If you had attended one of our previous videos on data formats, you may have learned about YAML. YAML is used extensively within Ansible, so it's pretty easy to read and interpret and build your own. The core components of Ansible, you've got an inventory file, which is again the inventory that we had talked about previously, one of the value adds of these types of systems. You've got your modules, playbooks, and an Ansible config file, and we'll talk about these just in a second. So this would be what an inventory file would look like from Ansible's perspective. It is written again in YAML, so a bunch of key value pairs. If you had, again, watched that previous video, you might be able to read this and make some sense of it. But we are basically stating what our data center fabric looks like in this specific case. So fairly easy to extend, fairly easy to work with. It can be edited in any kind of text editor of your choice. We also have the Ansible playbooks. Now, these are also written in YAML, so it's relatively easy to interpret as to what's actually taking place here. And then we have the Ansible modules, which make up the task aspect of what we're trying to accomplish in Ansible. So you can look at these modules. In this case, we're calling the module for Juniper_Junos_RPC, which allows me to execute RPC calls on Juniper devices. But what that's really calling in the background is a block of Python code that Juniper had developed specifically to run within this automation framework. So this is how we call in the vendor modules to do particular tasks on our devices. And we also have the concept of an Ansible configuration file. Now, the config file is kind of an interesting one because this concept exists also in Nornir and many other tools, that the automation framework ships with a bunch of default settings, and they give you the opportunity to overwrite those default settings. And they're typically in the format of something along these lines of a text configuration file. Ansible's config file is the only thing that's not written in YAML, probably yet. And so It's written in an INI format. Again, pretty easy to understand. Key value pairs separated by a equals sign. Again, the intention of a config file is to overwrite the system defaults when working within an automation framework. So that's really the four main components within Ansible. Inventory, again, is a mapping of all of your devices. Maybe you want to throw some IPs in there, some other attributes. You do that in the inventory file. Most of the time, though, for large scale networks, the dynamic inventory plugin is leveraged to reach out to services like Netbox or an internal CMDB to pull in your inventory dynamically. So you do not want to be managing text files with hundreds and thousands of networking devices. That's just not fun. Who wants that job? So that's the concept of inventory inside of Ansible. Playbooks are the actual execution. It's a list of different tasks that we want to execute within our run. The modules are the bits of pre-packaged Python modules that allow us to perform a certain function. Most of the time, they're actually developed by a networking vendor, so they're pretty much top-notch. But a lot of the other ones are written by the community. And I would say almost 90% of those in the community are top-notch as well, at least those that are commonly used. And you have the ability as well to build your own. I've built some for the Juniper Mist platform. It's a lot of fun. It's a really good learning experience. I'll say that much. So let's talk about some of the strengths, some of the weaknesses of Ansible. One of the really important things, this applies to not just server admins, but also network guys as well and gals, is that it allows you to quickly transition some of your change controls that you have, maybe on a text file or just a bunch of commands for a config change. Ansible is really easy to just kind of copy those commands, paste them in a playbook, and have them run in an automated fashion. Not just faster, not just safer, but also in an idempotent fashion. And idempotent is a word you might hear a lot about when talking about automation. If you don't know what it means, it's another somehow it became a loaded term between groups as well. But Calvin's definition is it basically allows you to execute the same playbook with the same tasks against a device continually, and if that change wasn't going to actually make a difference on the device, it won't actually make that change. So if we had posted our playbook before, when we saw the one that set the router host name to router 1, when we execute that the first time, if that play is if it actually changes something, we'll get some feedback. But I can run that play a second time, a third time, a 942nd time, and if that host name was already changed on the first run, it won't try to make a change going forward. So idempotent is extremely powerful in the networking world, where making configuration changes, even just pasting a configuration on a device that the configuration is exactly how it is, you have an opportunity to break state between devices. It's nasty sometimes. So you got to be super careful. Idempotency is really important for you. Agents. So when I say that Ansible is agentless, that's because it's built off of SSH. Everything that it does is completely through SSH, which one is inherently secure, right? Because we trust SSH. Until proven otherwise, we have reason to believe in the system. And it doesn't require any kind of piece of software or agent to be deployed on the remote device. Some of the other automation tools out there, Puppet and Chef, they require an agent to be installed on the networking device in order for them to be able to interact with it. That is typically frowned upon in the networking world. You don't want our router or switch to have really anything on there that's not like vendor blessed and certified that it won't hurt the device in some kind of way at some time. So being agentless in the network world is huge, and relying on SSH is huge. So those are really two big benefits within Ansible. YAML is used extensively in Ansible. It's, as you saw, it was in our inventory file, it was in our playbooks, It's in all other aspects of Ansible except for that Ansible config file. But YAML is typically, it's pretty easy to work with. If you've got zero or limited developer experience, sometimes it's a lot easier to just kind of jump into the world of YAML rather than learning JSON and XML. YAML is arguably easier to operate and easier to work with. And again, Ansible can be extended. You can build your own modules. You can build your own plugins. You build collections and roles and all kinds of great things. It's relatively easy once you get proficient with Python. Let's talk about some of the downsides. The downside is, again, it's on YAML. Its a reliance on YAML is sometimes pretty annoying, I guess is the best way to phrase it. YAML wasn't meant to really do complex operations. No, if this then that type of thing. YAML was just basically a data format, and so Ansible had to do some magic in order to get the YAML into their domain specific language, or DSL. And that working in that kind of paradigm can get kind of annoying sometimes. It's just difficult to work with at moments. The vocabulary used by Ansible, this is just a personal gripe. It's not good. I don't agree with the words and phrases that they use. Maybe you're different, but like for instance, if I want to print the output of a variable to the screen, I want everyone to see it. You would typically think that function would be called print, but in the Ansible world, they call it debug. And I guess you could make a case. I can understand why they would call it debug, but it's not really user friendly. Like, it's developer friendly, but not really user friendly. Some of the words, and Ansible Tower and Ansible Core sometimes use different words to really mean the same thing. So it's a little bit, it's more of a gripe. So please don't look at it as too much of a weakness. Debugging errors can be difficult in Ansible. If you've ever worked with the template engine that Ansible uses called Jinja 2, if you template a lot of configs and there's something wrong within the template, Ansible's going to produce like hundreds, 200 lines of red text on your screen. You're going to think that you broke something in space, but it's not. It's just it's a really long debug error, and it can be kind of obnoxious and annoying to kind of parse through all of that to figure out. So yeah, debugging can be a little bit of annoying. This is another, might just be a personal gripe. It might be more felt within the community as well, but Ansible has had some really major shifts within the last couple of releases, within the last few months. So I could argue that that's a sign that the product is maturing. It's getting better. It's getting more refined. But at the same time, it can make it difficult if you operate with the tool a lot, because you have to learn how to do things, the same tasks, in a different capacity. You can usually stay on a version of Ansible for an extremely long period of time. You don't have to always go to the latest and the greatest, but there are differences between them and how they operate. So that's kind of annoying. And Ansible is arguably probably the slowest of the automation frameworks out there. It's still going to be much faster than you. It's faster than me by a lot. So it's not that the performance is terrible, but it isn't great, and it's kind of felt, and it's kind of well known. There's some reasons behind the scenes as to what's actually happening. I'm not smart enough to understand them. I just know that when I use Nornir, things are much better. But it's not too bad. All right, what's the right environment for Ansible? This will kind of wrap up our discussion. Ansible is probably the right tool to at least consider when you're working in the capacity of a team. If you're an individual and you're just writing Python scripts 1 and 2 and 3 and 4, and you feel comfortable managing them, then hey, maybe it's not a big deal. But if you're working with a team, specifically maybe a mixed team, maybe you've got one guy or gal that knows Python really well, and everyone else is kind of more of networking interested only, then Ansible is definitely the right place, or at least an automation framework in general, is typically the right place to consider the tool. I lost my face. Too much red in the Camry. So, uh, but I mean, those are typically really good times to consider an automation framework in general. Is that when you've got multiple people that need to work on it, having a common set of tools, a common set of terms to communicate within each other, and be relatively easy to understand what other people's code is doing, then that's a good thing. That's a good thing. Another great thing about Ansible is if you just need a really quick win to show leadership that you're doing network automation, Ansible is really good at showcasing this, and I'm sure you can come up with your own metrics to talk about how much time you saved doing it. But it's really great because there's the barrier to entry is considerably lower than many of the others. Um, Ansible is also a good fit if you'd like to pay for support. Many of you have work in an environment where support is mandatory for all products that you touch. Um, if you work in that type of place, hats off to you. But here, Ansible is obviously supported by Red Hat, and they have IBM backing them. They're not going away anytime soon. So Ansible is a really good place for that. Also, Ansible does provide a graphical user interface called Ansible Tower. There's even a upstream release or a free open source release where all the development for Tower is, and you can download that and run it without ever having to pay Red Hat a dime. And that's called AWX. It's bleeding edge and it's a little rough sometimes. So please understand what free buys you. Might prove difficult to to actually ingest. But anyhow, let's move on. Let's talk next about Nornir. Same kind of workflow. We'll go over a foundation overview, and then we'll cover some real live examples of both Ansible and Nornir. We'll show you side by side kind of what it's like to actually execute on our networking devices. So Nornir, fantastic project. Very big fan of this. It was created just a couple of years ago. The developers, the two main developers, one is the gentleman that created Napalm, David Barrasso, and NetMiko came from Kirk Byers. There are many other contributors to the project, but it is extensively focused on networking. I say here it's exclusively, and I would say that's still accurate, but you know that the function of using Nornir is primarily on networking devices, but with the latest release, you can actually kind of think past those boundaries. The nice things about Nornir is extremely lightweight. If you have any experience in the web development role, and you understand like the difference between Flask and Django, you'll hear often that Nornir is the Flask of network automation, meaning that it's a powerful, lightweight framework, but you pretty much have to roll up the sleeves and actually get all the coding done yourself. But one thing that's really great about Nornir, my goodness, it's fast. It's great. It's excellent. These developers really know what they're doing here, and Python screams with Nornir, so it's a lot of fun to use. But being a pure Python framework has its own strengths and weaknesses. We'll definitely cover this, but with Nornir, you could argue a strength and maybe a weakness, depending on the person, is that it is completely written in Python, meaning you are still going to have to learn Python, become proficient with it, understand what it takes to be a good developer in Python to actually execute a successful Nornir automation script. So depending on who you are, that might be a blessing from the sky, or it might be a curse. Perhaps you just don't like this type of stuff. Nornir it resonates differently with different people. So the components within Nornir, very similar at a high level with Ansible. There's a lot of more specific things that I didn't touch upon within Ansible. But with Nornir, the idea is to keep things relatively lightweight, keep them relatively simple. There is an inventory management, not only with the static files, as like we saw with Ansible, but also dynamic inventory as well. There's a, a blossoming ecosystem for plugins. Not a whole lot right now, but those that are available pretty much can solve almost any of the tasks that you have. The execution. So again, Nornir, being an automation framework, will handle the building of a connection to a remote device, either through NetMiko, NCC client for NetConf, or NetPalm, or all kinds of other network drivers out there for you. And then there's a config file as well. So with the Nornir, the inventory looks a little bit different, but it is a YAML based file because that's arguably still the easiest mechanism, the easiest data format for us to work with as humans in our limited human brain capacity. This is typically a little bit easier to work with. But just because, again, the data format of an inventory file is in YAML, so is the config file, spoiler alert. That doesn't mean that it's not a pure Python framework. Everything from an execution perspective is still 100% pure Python. In fact, what a segue. Here is an example of a Nornir automation script. Let me hide my face. So you can see this is really expecting you, the human being, to be able to develop this Python script in order for it to execute your tasks. So extremely important that you understand that you need to be somewhat proficient in Python for this. Now the plugins are actually imported into the scripts, kind of similar to what we saw within an Ansible module. We call it, but as you might know, within Python, we have to declare that we want to import a plugin. We didn't have to do that on the Ansible side, but just, I mean, Ansible's masking all of that in the back end. It's also importing, but here inside of the Python script, we actually have to declare it. I've got a couple of different plugin examples here. I just thought they were pretty interesting. One is we're importing the Juniper PyEasy package for Nornir. This one allows us to get the configuration from a remote device over NetConf. And I'm also importing an inventory plugin for Netbox. So I can just point to my URL, give it my API token to authenticate, and then I can get my full list of networking devices. So pretty easy if you think about it, pretty easy on how some of this is declared. So yeah, and the Nornir config, again, spoiler alert, as I mentioned earlier, this is also written in YAML, but again, the intention is just like it is in Ansible, the capability of overriding some of the system defaults within the actual framework itself to make it work a little bit easier for you. In Nornir's case, the line number 3, it says num workers. You might have pieced together that stands for number of workers, meaning that there would be 10 active workers with this configuration file. It means I can execute the same task against 10 devices at the same time. And Nornir will handle all of that. Multiplexing isn't the right word, but we'll just say multiplexing of SSH or NetConf sessions to remote devices. So really, really awesome, really easy to tweak and tune to make it as you see fit. So let's talk about some of the strengths and weaknesses again. The strengths, it handles all the asynchronous connections for you. Go fast. Yeah, there's no lie to that. That's really a huge benefit within Nornir. Extremely lightweight and thereby very flexible, kind of like what Flask is. Again, you'd probably have to have some experience in the web development world to really understand that parallel, but it is an apt comparison. It's also agentless. It also uses SSH as its transport mechanism. There's no DSL to be learned. I'm not talking about your home internet connection DSL. What I mean is that there's no domain specific language. I had talked a little bit about this earlier. Ansible is almost entirely based on YAML for almost everything inside of Ansible, but YAML wasn't built to do some of the complex functions, so Ansible had to create their own DSL or their domain specific language. They frame it on YAML, but you need to learn that DSL, and that itself is can be annoying and obnoxious to someone who's got a lot of experience in the development world. So no DSL is needed to be learned because it's just pure Python. And it also can be extended when needed. Now, weaknesses, again, this could go either way, depends on who you are and your skill set, but its reliance on Python, it does create a barrier of entry. You need to be somewhat proficient in order to really consider using Nornir over Ansible. The community support is good, but it's not great. And what it would be a representation of a great user community would be Ansible. 100%, probably one of the better online communities that I've seen out there. Simply fantastic groups of gals and guys just ready to jump in and help out at the drop of a hat. And we'll give some links to where you can find people like that towards the end of the deck here. Weaknesses, it is not really designed to manage other types of infrastructure. That might be a loaded statement because the latest release is a little bit more open, but just know its original roots and genesis is in networking, so that's really where all the plugins are today. We hope, at least I hope, to see additional plugins, things for VMware, maybe some storage, maybe some cloud APIs. Who knows? I'm hoping to see that within the near future. And this is arguably a weakness. It's still a young project, so you can expect some major revisions, kind of like what we're going through right now with Ansible. I mean, I was writing this curriculum. We were on 2.10, and then as I'm recording this, like I got a notification today that they're moving to 3.0, and it's just a major thing. We're going through it right now. Nornir will probably it actually argumentally just went through a pretty big facelift as well. Expect more in the future. You just got to know to look for these types of things. Don't always download the latest package of a framework or any kind of software. Do your due diligence. Find out what's the recommended one, and always go with that. Right environment for Nornir. Obviously, if you've got some experienced Python developers on your team, fantastic way to go. Speed is a priority. Nornir is absolutely outstanding at managing multiple connections. Ansible is great too. But if speed is a priority, typically you would lead with Nornir, or you would go with a compiled language, maybe something in Golang. Um, there's other options out there for you as well, and obviously no need for a GUI. There's no kind of APIs. There's no graphical user interface for Nornir. I don't know many people that open up a Python script in Vim that would ever want to admit that they use any kind of graphical user interface. So there's another really good reason to fall into the Nornir camp. Now, where to go? Obviously, all my recommendations always start with NRE Labs as much as you can. Leverage that website. It's one of the greatest tools out there, completely free, no login, no tracking, no cookies. We don't even put our name on the project that Matt Oswalt had created for us, but absolutely fantastic. Highly recommend it. Cannot recommend it enough. Juniper VLabs, if you want to get in and test out some of this automation, we do have a couple lab topologies that have a Linux server on there. There's nothing to technically stop you from installing Ansible on that Linux server. It all gets destroyed at the end of the lab anyway. So if you want to learn Ansible, that's the way I got good at it. Was I used Juniper VLabs as a customer, completely free as well. Ansible, again, really great community. Here's some really great places to find more information on documentation on these two projects. And as always, if you ever want live human back and forth automation help, Network to Code is the absolute best place to do that within their Slack channel. Can't recommend it enough. So that's it from the slide presentation side. Let's actually show you some live demonstrations of both Ansible and Nornir. Our first demonstration today is going to be focused around Ansible. And spoiler alert, I already have some examples pre-canned because I honestly, I don't want you to have to watch me code everything, but I'll talk through the different pieces that actually are relevant, and hopefully you can pull apart which pieces do what. So let's move first into my Ansible folder here, and let's take a look at my Ansible playbook. I'm gonna close my terminal for a second. This is everything within my Ansible playbook. What this is going to do is it will reach out to my devices in my data center and pull all the LLDP information from all the interfaces and then store that output into a JSON file so that I can revisit it or maybe pass it on to another piece of automation software to do something really fancy with it, maybe post it to a Slack channel, maybe open up a ServiceNow incident, all kinds of things that you can do once you have the data in a structured format. So this is the playbook within its entirety. Best practices within YAML is to start your file with 3 ticks, which you will see on line 1. It's not a hard requirement these days. And Ansible is definitely flexible about this. You don't have to use 3 ticks. I like to because I like to be a good kid. I also like to be very good to myself by leaving a lot of comments, and not even just leaving comments, but I like to leave them in a really obnoxious way that they pop out on the screen. So lines 2 through 4 is just me adding some comments so I understand what's the function of this playbook, rather than having to read it all and figure it out myself. If you just leave yourself a little hint, you will thank yourself later for it. All right, so line 5 down is where the actual playbook really starts to begin. The first thing that we do on play 5 is we say we want this playbook to apply to all of our hosts. Now, all is a special word. It actually references our inventory file. There will be a group at the top called all, which all other groups and all other devices of those other groups will be a part of. So this is a really great way of just say, hey, just all the devices within my data center. Connection equals local. This is a networking specific thing. I kind of alluded to it earlier where Ansible was originally developed for server automation. And the reason why I bring that up is that Ansible's default behavior is that it will take the tasks that you have in your playbook and it'll carve up specific Python scripts for every single host. And then it'll secure copy that Python script over to that remote server, have it execute, and then it deletes the temporary Python script that it copied over, and it sends the output back to Ansible. That's the underlying architecture within Ansible of how it's actually doing things. Now, for servers, that's great because that means it basically delegated all of the tasks to the actual server to actually run rather than trying to command everything from a central location, which speeds it up, which makes it act a little bit more distributed, if you will. The problem is that on networking devices, you can't just copy over a Python script and run it willy-nilly and expect it to work. Even on a device like Juniper that has Python available for you, there are steps that you need to do in order to be able to execute Python scripts. So what we have to tell Ansible in line number 6, we say connection local. What we're really saying is, hey, Ansible, I want you to do this operation. I want you to be in charge of managing all the connections and all the tasks associated with it. So rather than try to punt these tasks off as small Python scripts to the remote network devices, no, we want you to actually do all of it. So that's what line 6 is. You probably wouldn't use this very often for other cloud APIs or for server or storage. This is kind of a network thing. Roles, so lines 7 through 8, what I'm telling Ansible is I want to import a third-party package or a module or in this case, a collection of modules. Now, these are the official Juniper modules that are produced by Juniper, maintained by Juniper. And if you're going to be doing any automation to Juniper, I highly, highly recommend that you use these in contrast to the ones that Ansible actually generates. Highly recommend these. It's a little controversial take, believe it or not, but please, in any case, try to stick with the vendor that actually produced the modules rather than the ones that Ansible provides. So line 9, this is kind of the jump off part of where we're actually going to start doing some automation tasks. Everything above line 9 is just kind of giving Ansible a little bit of information on what's going to be doing what and what are some of the characteristics. Lines 9 down are where we're actually doing the tasks. So I have 2 tasks that are listed here. And if you remember in YAML, or if you watch the previous videos on YAML, you would know that we denote a list with this indentation, and each object in the list has a hyphen associated to the object. So from that, I can tell I have 2 tasks that are listed right here. The first task, I'm giving it a name. This doesn't have to be here, but whenever the Ansible playbook executes, if you have a name value that's associated to this task, then it'll print out to the screen, and it kind of helps you on very long playbooks kind of have an understanding as to what's actually happening at each step of the way. So the name of this task is retrieve LLDP neighbors with netconf. We can see that I'm importing the first plugin or the first module. This one is called Juniper _Junos _RPC. And I can find out the available modules to me by reading all of the documentation or just kind of glancing over the documentation. You don't have to read it all, but just looking at the documentation for the Juniper.Junos roles. That's how I found out, hey, I've got this module exposed to me called RPC. I'm passing it some basic parameters. I'm saying the host is going to be equal to whatever the host name is in my inventory file. And my username and password will be Juniper or automation with the password Juniper123. And that I'm going to run a remote procedural call or an RPC over the netconf API. And I'll be asking it, so I'll say, get LLDP neighbors information. And you can find these RPCs by just doing any operational command on your device, doing a pipe and saying display XML RPC, and you'll actually see the RPC printed out to the screen for you. And just copy that and paste it here in your playbook, and you're an automation wizard. And now we're going to create an object called output _ LLDP _ neighbors. And that's where we're putting all the output into, is that object. The way that we create an object in the Ansible world is we use the word register. This is one of the things where I said that I disagree with some of the vernacular that's used within Ansible. I don't think register is the right way. But anyway, that's how you create a new object in Ansible. The second task here, and I promise we're about to get started. The second task is where I'm going to actually take that output of output LLDP neighbors, and I'm going to write that to individual files. And the way that I do that is I'm going to be using a module called copy. This is a built-in module from Ansible, and I will pass it a couple parameters. One is the content. Content will be equal to my output LLDP neighbors dictionary that we get back from the RPC calls. And the destination will be a specific directory, and the files will be named after the name of the host itself. And so I hope that makes sense. Before I execute, let me talk about the other 2 files in this project directory. One is the inventory file. Remember, in Ansible, actually in all automation frameworks, there's typically some kind of mechanism to represent your devices. This is where that all group came in, where we talked about earlier when the line said host all. Here we can see there's a group called all at the top of my inventory file, and everything that's nested underneath there, including all the variables, default variables we're giving it, as well as the other groups, this spine and leaf group, and all the hosts, and everything in there is all represented by that all object. Now, I am declaring this is the name of my device. So inventory host name is equal to what I have highlighted right here. You can also see that I'm also declaring a variable called Ansible _ host. This is what the Ansible server will actually use to reach out to your networking device. So if you had a static IP, you would type that in here. You would say 192.168. 105.11. But if you have DNS, you can also use DNS as well. It doesn't really matter. It's pretty flexible in that way. There's my inventory file. I do have a couple of variables assigned in here. One is Ansible Python interpreter. If you ever run into a problem with Ansible telling you that it can't find Ansible or it can't find some other thing, search for this term. It's probably going to be your saving grace. It's a whole other gripe that I have with Ansible, and I don't have 15 minutes to explain on it. Directory, backup directory. This is where we're actually going to store the output of our commands. If you remember, we reference output directory as the destination for our files here. So I'm saying the backup directory is a folder called output, which I have right here. It's just an empty folder right now. And then all of our output will be written to files within there. The last thing to show you is the Ansible config file. Inside of here, I have some basic setup parameters. I don't typically build an Ansible config file every single time I have a project. What I have found over the years is that I have a much longer Ansible config file that I pull from my latest project. So I'll use the same file across most of my projects. All right, so let's actually get into the execution now. I'm going to open up my terminal by typing in control and tilde. And I can see that I've got let me see if that can be elevated just a little bit, pump up the volume on it. All right, the first thing I need to do is make sure that my Python virtual environment is activated. And if you didn't have an opportunity to watch the Python introduction, this probably won't make a lot of sense to you, but I'm going to go ahead and activate a Python virtual environment called Ansible, where I have Ansible installed. Oops, I can check that by typing in pip freeze grep for the word Ansible. Here I can see I have Ansible 2.9.16 installed. So the only thing that I actually need to execute to make this work is Ansible-playbook, and then the name of my playbook, which in this case is lldp.yaml, but I'm not in the right folder directory. So let me clear off my screen here. Let's see, there we go. And change into the demo directory, Ansible, and try again. Ansible playbook, lldp.yaml. And we get immediate feedback saying that the juniper.junos role was not found. Now, previously, I criticized Ansible for not having very descriptive error messages at times. This is an exception. This one is actually pretty good. It tells us that in our playbook, we're trying to call in this juniper.junos role, but we haven't actually installed it. Sorry to get sidetracked, but I had mentioned previously one of the weaknesses with Ansible is that it had recently gone over some major changes. One of the major changes is that all the vendor modules have been effectively removed from Ansible core. Now you have to install them from Ansible's external package library. And honestly, that's the right way to do it. That's the best way. I understand why. So let me just show you what it's like to install the Juniper modules on Ansible. I'll use Ansible Galaxy. Ansible Galaxy is the name of the external repo. I'll say Ansible Galaxy install juniper.junos. And this will download the roles from Ansible Galaxy and install them in my local directory. And here I can see that I have a new directory on my computer called roles. And inside of here is a folder called juniper.junos. And there's all the things necessary to make this magic work. Let's clear our screen and let's try this again by saying Ansible playbook. And by the way, that's going to be a one-time task within setting up your Ansible playbook. After you've installed the roles, you shouldn't have to do it again. Ansible playbook, lldp.yaml. And now we're reaching out to each one of the devices. And we did show LLDP information and or show LLDP neighbor, and we are looks like we got some output here into our local folders. So this is what we are expecting. So before I actually show you the result of the file, let me talk about the execution of Ansible because it's pretty interesting. I said I said Ansible was slow, but as you can see, it wasn't that slow. We logged into 6 networking devices and ran commands and then stored the output into separate files. Did it pretty quickly. So when we execute the play, here you can see this is the concept of a play. Now, a playbook can have multiple plays within it. In our case, we just had one play with multiple tasks. So the first line that you saw here in the output is play. It's just telling you, hey, let me just collapse that. First line right here saying play, saying we are started at this specific play. Now I didn't give it a name, so it just printed out the host that it's affecting, which is all. Now the next thing is where we actually see our first task. This is, again, as we denoted right here, lines 10 through 16. We are executing our first task. Now, you'll note I gave it a name, retrieve LLDP neighbors with netconf, and I put a little extra, what do you kids call it, hashtags in there. And that's just to help me whenever I see it execute on the screen, my eyes lock in and I can see exactly task, retrieve LLDP neighbors with netconf. Now, what you see is the text that comes back from each device. It will say okay, and it'll have the green text of the host name. That's basically just letting you know, 1, the task was ran successfully, and 2, the task did not change anything on the device. So it came back and reported green as okay. Now contrast that with the second task that we have executing here called writing LLDP to file. You'll note that again, we see each one of the devices listed out, but the result is actually, it's not okay, it's set to changed. Changed meaning that something was changed either on the local device, on the remote device, or on your local computer. In this case, it is on my local computer because we wrote files to the disk. So there was a change for that. And we'll see a recap of the play. It says overall, we ran 2 tasks. They both came out okay. One of them was a changed operation. One of them was not. And if you had any kind of problems, or if you skipped a task or skipped a device, you would see different colors show up. Errors are going to be red. Skips are going to be colored blue. Now let's take a look at the output that we got here. I can see that I've got this JSON file. So the output was actually sent to us in JSON, and I can beautify that in my IDE. And sure enough, this looks like the LLDP information that came from Leaf 1. Leaf 1 says it's got a connection to Data Center Spine 2 and Data Center Spine 1. Here are the specific ports. Here's the remote MAC address of the chassis on the remote system, interface names, and it should look quite the same, except on the spines, you're going to have, I think, 4 connections instead. So, but other than that, again, it took all in all a couple seconds to execute. Like I said, it's going to be faster than you and I, and that's okay. It's still not the fastest in the world, but hopefully that gives you kind of a look and feel of Ansible, and hopefully breaking down the playbook line by line kind of helped understand how you would go about building your own or extending this. Let's move now over into Nornir. Back out a couple directories and say Nornir and clean the screen. Now I have Nornir installed in a separate Python virtual environment. This is to prevent conflicts with packages and such. So I'm going to hide my face and I'm going to say source virtual environment Nornir bin activate. That's going to activate my Python virtual environment that has Nornir installed. And I could just say pip freeze grep for the word Nornir. And I can see that I have Nornir version 3.0.0 installed. I've also got an additional utilities package that, if I remember correctly, that actually was just attached as a dependency within Nornir, but it is a separate Python package itself. I also installed a Nornir plugin, right? So Ansible's got modules. It's technically a plugin. And Nornir has got, they call them just raw plugins. Everything is written in Python, so we'll take a peek at that as well. But in this case, I've installed a Nornir plugin for PyEasy, and let's just go ahead and execute this. Actually, before we execute, let's talk about our playbook. There's a few more files that I have. That is quite unique because most of the time Ansible is going to have all the files, but Nornir can maybe have some external configuration files, and that's what I've got here. This is the actual Python script. Let me see if I can't increase the size of the screen for us to talk through. The very first line here, I'm importing a plugin. So I'm importing a specific function from a plugin. The plugin I'm importing is the one that you saw that we had installed called Nornir underscore PyEasy. Now I'm importing a specific function called PyEasy underscore sec underscore zones. The idea is that this module is going to print out to the screen the security zones that are active on your firewalls. And then I'm also importing the main function of the Nornir package. And line 3 shows me importing a better print utility than the one that comes packaged with Ansible. I'm sorry, the one that comes packaged with Python. Python's got a built-in module called print. Here, I'm actually importing a better one. It just makes things nice and pretty, and that's what I like to see. And so, and on line 5, I'm importing the OS. It's confusing, but it lets my Python script understand which directory that it's working in. And that's important because on line 7, I'm creating a variable called script directory, and I'm setting it equal to the current path that this file is set in. So that's what you see right here. That's why I'm importing the operating system Python libraries that I can do things like find out what's the name of my directory that I'm working within. All right, and then line 9 is where we actually instantiate the Nornir functionality. I'm creating an object called nr, and I'm setting it equal to the instantiation of Nornir. And within that instantiation of Nornir, I'm also passing it a configuration file. Remember, we had talked about each automation framework typically has a way of overriding some of the defaults. Nornir is no exception. In this case, I'm passing it a file, setting it equal to script directory, which is our local working directory, and a file named config.yaml. If that doesn't make sense, I'm just basically overriding I'm telling Nornir, I've got a file on my computer and it's got some settings that I want you to use to do your task rather than rely on your defaults. All right. Now I'm creating an object called firewall, and I'm setting it equal to that Nornir object we created right up here. That's the instantiation of Nornir, but I'm also applying a filter. And I'm saying only give me the output for a firewall named branch 0 firewall 0. All the other devices I don't care about, so don't provide that for me. And then here's where we actually run our Nornir function. This is the function that we had imported up here at the very top. So I'm creating an object, I'm calling it response, and I'm setting it equal to us running the Nornir object, which had kind of taken on a couple different names throughout its life cycle. At this point in the script, it's called firewall, with the filter of my firewall in there. And I'm saying I want to run, and here's the name of my task. I want you to run this specific task, and here is the task or the function that I want you to run. Now, this is something that we imported. We'll get to that just in a second. But here, I'm actually just printing out the response to the screen. So I probably actually don't even need that. I'm just creating an empty list that doesn't really give us much at this point in time. But here on lines 20 through 21, this is where I'm actually printing out to the screen the response of my script. So as you can tell, Nornir is extensively Python through and through. Its execution from top to bottom, this is just Python. Now, we do set some configuration parameters with the YAML markup language, or the YAML data format, just because it's easier typically for humans to set parameters in that context. So before we execute this, let's look at those configuration files that we had set up. Here I've got a config file. This is overriding the default nature of Nornir. You can see I'm declaring, here's my inventory. I'm going to use a YAML inventory file. There's a lot of plugins, by the way. You can use dynamic plugins. We talked earlier about using like Netbox, making a REST API call. This is where you would declare that inventory plugin. I'm also passing it some parameters. I'm saying that my host file, meaning my list of hosts, is listed as in my local working directory with a host.yaml as its file name. And I also have a group, so I can have hosts and I can have groups, and I can throw host into groups just like we did with Ansible. And then I can assign variables either at the host level, at the group level, or at the default across the board level. So I'm telling Nornir where my group file is. And then I'm also telling it where my default variable file is right here. And this is where we change the behavior of Nornir. In this case, I'm telling it, I want you to run multi-threaded, and I want the max number of workers to be 10. So depending on how many devices you have in your environment, you may want to adjust this number. If you've got only 4 devices in your network, well, why are you a network engineer? That doesn't sound like a lot of fun. But let's just say that you did. It doesn't make sense to have the workers set to 10. You could keep it there, or you could set it to 4 or 2, whatever. If you had 10,000 networking devices, you'd probably want the number of workers to be increased to maybe 100. But just know you're going to scale up the amount of resource utilization on your Nornir server. All right, let's look at the defaults. This is my default configuration variables that I'm passing in. Here I'm saying in my group called firewalls, I want the username to be automation, and I want the platform to be recognized as Junos. We should probably take a look at the actual groups. Here's my groups. I'm creating a group called firewalls. I'm saying my username is automation. My password is Juniper123. My platform is Junos. I'm also declaring a new pair of variables here. One called DNS server, one called NTP server. The only reason that this is in here is that you understand that you can actually set parameters or variables at the group level, and it'll apply to all the hosts that belong into there. Now, if we look at the host file, this is my actually inventory file of my devices. You can see that I have individual firewalls listed out here, as well as their host name, which group that they're associated to, and if there's a specific other variable that I want to pass. In this case, I'm saying the node type. This is an SRX firewall. And that is it. So let's go ahead and look at my application, and I'll open up my terminal here. Oops. Let's get back to there we go. And let's say Python app.py. And what we're getting back is, well, first of all, it's kind of interesting. I got a new log information. So by default, Nornir is going to create a log file if it doesn't already exist on your computer, and it will update it. And if we just look into that really quick, I can see I got a timestamp what Nornir did. It said it is running the task of Pi security zones on one host. And if I look back into my output here, I can see, sure enough, this was one host, and I can see all of the security zones that came from that one host. It looks like I have a security zone called Internet, one called MPLS WAN, one called Trust, and one called Junos Host. And I can see interfaces that are associated to it. So all kinds of really great information. That was a single device. Now let's take that filter off that we had set earlier. I'm going to delete this line right here. And instead of the object being called firewall down here, we'll just call it NR, because we're going to run this without any kind of filter. And we'll see how long it takes to do the same task on 5 firewalls, I think 4 or 5 firewalls. I think it's 4. We'll see. Okay, so relatively extremely fast. We got some really great output here from all of the firewalls within our WAN. We can see all of the security zones that are configured and all the interfaces that are on there. All kinds of really great information. Now, I had mentioned earlier that this plugin is one that I installed from GitHub, and I just kind of want to show you that everything again in Nornir is just pure Python. what it kind of looks like wizardry. I'm just calling this specific function in. It's not wizardry. There's actually, if we go to the source code on GitHub for this particular project, if we dive into the actual source code, look into the plugins, I'll say tasks, and I think this one was called, yeah, there it is, pyeasyseczones.py. So this is the actual Python script that's ran whenever we call in that specific plugin module. So there's nothing but pure Python on here. If we kind of zoom in here, there's actually not even a whole lot going on in here. So again, Nornir allows you to build these plugins with a considerable small amount of code. Here we got the output from an RPC with just 18 lines of code, and it's repeatable across any Juniper device, any firewall Juniper appliance, I should say. And oh, look, hey, I know that guy. So this is the reason why I showed you. I'm painfully familiar with, not painfully, but I'm very familiar with this one because I did write this one. But you can also write your own and publish them. So have at it, ladies and gentlemen. So with that, we'll go ahead and conclude today's session on automation frameworks. We showed Ansible, we showed Nornir, we talked about the strengths, the weaknesses, the architectures, how they achieve that common goal, which is to make your life a little bit easier to automate. We gave you hopefully an understanding as to what tool is probably appropriate for which environment. And we showed two demonstrations, one using Ansible to get LLDP information, writing that to a file, and the other with Nornir, where we logged into a bunch of firewalls and we got all the security zones. Relatively easy, I guess, in comparison to writing these yourselves. And again, that's the true power within automation frameworks, is to make your life a lot easier. And I think these days we could all use a little bit of an easy button. I think we deserve it. So again, my name is Calvin Rimsberg. Thank you so much for joining me for this last hour plus. I hope it was beneficial for you, and thank you for viewing.